have a little more clarity on what I think SALSA should be. That's the Spontaneous Application Layer Security Addendum, and what I envision as a specification for what keepers of client data, such as businesses and government organizations, should operate like, so that they can interoperate and software can be sold to them and interoperate properly. And so I have prior videos where I describe what the need for SALSA, and I recommend those be viewed, and then you'll have an understanding of where I'm going with this. Anyway, the point is that TLS is not good enough. TLS secures out in the cloud, the net, but once it gets into an organization, there's no security requirements, and it's going to be hit and miss, and about whether your data is very secure, whether you're can count on confidentiality in any data that you give to organizations, and anybody who uses the net. Supposedly we have an average of 90 accounts. I don't really have 90 accounts, but I certainly have a few. I'm a bit reluctant to give personal information, being a technologist who's operated in the middleware of businesses. And the middleware is, once you get into the organization, you start keeping databases and etc. Shopping carts, purchases, credit card information, all those things. There's a need for greater security there, and standards that organizations have to adhere to, so that they abide the law in the Privacy Act, etc., and don't put you at risk. So anyway, I will draw a model that I've conjured up about the way a business would run under SALSA, and basically there's multiple tiers. They like to think of the back end as having tiers, but I'm going to use that word with a loose association with the software term back end tier. Anyway, there's data that the business will have. It has almost nothing to do with the clients that access it, and that'll be like products, inventory, and perhaps documents. So those things, when you first hit a web page or an organization, you don't have to worry about secrecy with that. And they kind of call that static, but I guess inventory is not really static. And you might keep a cart, and you might have a cross-reference number out in your browser that helps remember your cart. Sometimes you keep that in your browser, but it can also be kept as some state in the organization. In the browser, it'd be kept in a thing called a cookie, and you can research what cookies are. But inside of the organization, you probably keep that in some kind of database, a cache database, it's called, which is just some temporary data store. So that is not very sensitive either. None of this is very sensitive. But once you start accessing things relating to your very personal information, I'm going to call that another tier. This is called the non-sensitive tier. Way up over here would be a sensitive tier. So that would be your name, address, phone, email. These are things that have to be extremely well protected, because they will help somebody steal your identity, they will help somebody stalk you, etc. So those need to be handled with more security than they do right now. Right now, since everything that comes into the organization is unciphered, it's plain text. All of this can just be viewed, basically. You know, of course, data goes through machines inside of the business. In each one of those machines, somebody can get in and set it up, look at the to where they can watch data going across. Of course, so organizations are very large and not necessarily filled with the most competent people or the most adherent people or people who have passed background checks, very deep background checks. So it's going to be hit and miss as to whether data is going to go from out in the client securely into here without anybody ever, so many unauthorized people ever seeing that. So I'm rejecting that way of operating and recommending some more stricture. And here's how I decided that must go down. Firstly, what I just draw, this tier called the sensitive tier, which is basically the ID tier. So anything that helps identify who is accessing that organization, basically. But there's another sensitive tier, which would be ongoing operations information. An accountant would call that a ledger. So purchases, credit card accesses, payments, deposits, stock purchases and sales. Let's see, insurance payments, insurance accounts, etc., etc., etc. Those would be in the ledgers, basically. And so why would you separate these? So basically, a person would have a special number, a control number that nobody else would know. It would never go out here into the rest of the organization, but it will be in here associated with your activities, basically. So anybody who has access to the ledgers will never see anything personal about them. They'll only see these cross-reference numbers that goes to there. And theoretically, you could change that number so it did migrate over time and thereby make it difficult to catch up with somebody if you were looking to look into their data. So, so ledger data would only ever use a cross-reference number, never a name, never an address, phone number, or email, such things. And also things like race, sex, sexuality, etc. None of that. Merely numerical type things. And these will be cordoned off very well right here. This will be a whole nother system. And that'll be a whole nother system. As I mentioned in a prior video, a DBA will get approved to access this data and will have virtually access to all of it. I did recommend that the data be encrypted, so which, by the way, makes it impossible to search for. But keeping it encrypted from the outside, I recommend for SALSA. But you probably can't encrypt all of it because, like I said, it makes it impossible to search for. And you know, the job of a database administrator gone. So, but there will be database administrators and other people who can look into this data and handle it, work with it. They like to look into your data, so-called data mining, etc., 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 to find out trends and things they can, you know, sell people and other reasons they might look into trends. So that brings me to the second detail of this diagram. This is a very cordoned off zone. This is a little less cordoned off zone, But the DBAs who could mine this data and see this cross-reference number and this the specifics of any transactions would never get access to this one, basically. So they could never match personal information to ledger data. It's not the same people. So ledger data is going to, and their DBAs are going to be far less sensitive. So I'll erase that. That's handled. Now how to handle the very secure zone. A couple of details, approximately the same thing. Going to segment it and cordon it off, what's called sharding. So in sharding, you'll perhaps you'll make different database systems, different storages of information, and keep some in each one of them. For example, you would keep every person whose last name starts with A in one system. Everybody's name starts with B in another, and that is C. So that would segment them. There would be absolutely no association between those. And you could assign separate DBAs to those systems. That will limit the access of this DBA to any data. So rather than a single database administrator having sweeping access to the whole thing, even though they don't need it, they will have a zone of responsibility, and things that happen in that zone of responsibility they will be accountable to. Narrows down the the vagaries of figuring out who might have been responsible for something, basically. For a very large system like, an insurance company, State Farm, that'd be very easy because they have millions of accounts. They could, this one could be 1 million accounts, and you could have 10 DBAs there, and this would be another million accounts, and then another 10 DBAs. So, but it wouldn't be 20 who have access to 2 million. It would be 10 who has access to this million, 10 who has access to this million. Narrows things down what they have access to. And that makes sense because the concept of least privilege, which means you only have as much access to that which you need. And since that's about all the workload they can handle, that's all the access they can need. Now, the other issue is not just DBAs who handle data. The other issue is customer service people who have access to data. So, when a customer service representative type person has access to this data, should they have access to all of it? No, they shouldn't. They should only have access to the amount of people they are going to and should service. So what you will do with each of these entries in here, each of these people, there will be a list of representatives who can access them. You wouldn't want it to just be one person. You could have one main person, but you'll have a list. If there's 5,000 CSRs, in an organization, you don't want 5,000 CSRs having access to 5 million different accounts. You maybe want each account to have 5 possible CSRs. So I have an access control list. So you use sharding to limit the DBAs who have access, and you use ACLs inside there to limit the account service representatives access. And of course, everything's supposed to be recorded anyway, but human activity is a fraught with error. So it should adhere to this type of thing. Now, back to the SALSA itself. Throw in some chips into this one. When the data comes in, it needs to be blind to everybody. You have a right to nobody but nobody seeing your accesses to your data, either the ultra secure identity area or the medium security ledger data. So how are you going to do that? TLS ends here. It's pretty good outside, but on the inside, every person in the background has the wherewithal to find the secure key. With the secure key, they could get on the data, or they can access the machine and put a little piece of software on there to watch for things people accessing. So this needs to be secure once it gets in here. So how to do it? I call it spontaneous because the secure key cannot just be something anybody in the technology department of the organization can get a hold of. It's got to be pretty secure. So, along with sharding the databases, you will also shard the back end, perhaps right along with it, and with each one of those chunks, you'll have a little SALSA engine that has very temporary secure keys. And as I mentioned with TLS, you need a certificate authority to vouch for it. What you need to do is make up temporary secure keys and get a public key for it out to a certificate authority. So you can automate that, but somebody's going to be responsible for it. Somebody's going to be liable for that happening. So what you will do is, and you don't want it to be all 10,000 people who work in the IT department pulling cables and playing around with the operating systems. You want to be very select individuals who have passed background checks and will be held accountable should something go wrong here. And you want to limit how much could go wrong. If it goes wrong in this shard, it's not going wrong in that one, it's not going wrong in that one, and the other 100 shards. So each one of these will be assigned a security officer who's had background checks, who's proven competency, and will be responsible for that zone in that short-term secret key getting its certificate to an outside certificate authority. So this getting into from the boundary of the business to the so-called middleware, the area where you start doing business calculations, you start looking up identity information, account information. Once you start doing that, you'll have another TLS layer basically that has a very temporary security. Why does it have to be temporary? Because it'll be discovered and eventually this data will be vulnerable. So it doesn't have to be extremely temporary, but it can be temporary. And this should be automated, but the system itself will be administered by a very select few people who have been background checked. And then this will be this data here will be in the dark, and the regular people who play around with the system will not be able to discern who is accessing accounts and who is doing transactions with the organization. So that's what I recommend: sharding the identity database and the middleware that interacts with it and the ledger, and assigning security officers to areas, and automating secure key registering with certificate authorities outside of the organization. And then all will work much better.